Hi, my name's Jacob and I'm from SUNY Delhi. Today we're going to talk about the anesthesia machine and how it works. So first, you're going to figure out where your source of oxygen comes from. Here at SUNY Delhi we have the H tanks, which I like to call the heavy tanks, in another room. So I've already went ahead and turned them on. Now from there, it starts out at 2200 psi. It is then reduced from a pressure reducing station to 50 psi, comes through the wall here with this green hose, and goes to the flow meter, where the flow meter takes the oxygen and brings it down again to atmospheric pressure at 15 psi. Okay, so from the flow meter it can go two places. It can go to the oxygen flush valve, or it can go to the vaporizer. So I'm going to start with the oxygen flush valve first. So the oxygen flush valve brings the patient direct oxygen. So it bypasses the rest of the system. So no CO2 canister, no vaporizer. So it goes to the unidirectional inspiratory valve to the patient. It is useful for giving the patient fresh air, a breath of fresh air, or it is useful if you need to dilute your gases. Okay, going back to the flow meter now. So the flow meter is right here, and we generally at SUNY Delhi like to say 1.5 is our safe number. And so we usually run at about 1.5. So it goes from the flow meter to the precision vaporizer. The precision vaporizer compensates for humidity, temperature, and back pressure. Okay, so it goes from the vaporizer, right here, to the patient through the unidirectional inspiratory valve, where they breathe in oxygen and sevoflurane in this case, through the patient, back to the unidirectional expiratory valve, where it then runs to the CO2 canister, which converts the carbon dioxide into calcium carbonate, where then the patient can rebreathe the leftover anesthetic gas and oxygen. That saves us money, and then it goes to the passive scavenging system after it leaves the patient through the unidirectional expiratory valve. When going through the passive scavenger system, if the scavenger system weighs more, the F-air canister I should call it, weighs more than 50 grams here, we're going to toss it because it no longer serves a purpose because there's activated charcoal inside and it absorbs the leftover SIBO in this case. Okay, and that's pretty much how the anesthesia machine works. Another useful thing to know is never leave the F-air canister down. These vents on the bottom need to be open, so put it on its side, down at the bottom or up here, wherever you need it. And another thing to know is how to properly estimate your rebreathing bag. So your rebreathing bag over here is going to go right here. And whenever you're using your rebreathing bag, you need to make sure you either hold this button down. This stops the rest of the system from having oxygen come through. And you can pull this button down and let it fill with air, and then you can give them a breath. Or you can close the pop-off valve, but your system should always have the pop-off valve on open when you're using it generally. Always make sure it's on open. But for calculating the rebreathing bag size, you're going to take your weight in kilograms, multiply that by 5, and then multiply it by the tidal volume, which is 10 milliliters per kilogram. And that's how you're going to get the size. You're going to always round up. So if you think that the patient needs 1.2 liters, you're never going to go with a 1 liter bag, you're going to go with 1.5 liter bag. Jacob from SUNY Delhi. Today I'm going to talk about how to properly leak test your system. So first of all, we're going to leak test the whole system right now by closing the pop-off valve. So you close the pop-off valve by twisting the knob here, and then you're going to take your thumb and you're going to hold over the end of it. You can use a cork or you can put it against your palm like this. Okay, so you're going to take your oxygen flush valve and bring the manometer up to about 30 to 40 centimeters of water. So you're going to fill this bag here. Using the flush valve, it bypasses the vaporizer because we're not going to turn the vaporizer on while we're leak testing our system, and it bypasses the CO2 absorber. Okay, so here what I'm going to do is fill it till it turns about 30. Okay, so right there it's almost about 40. Okay, so it should not go down less than 10 centimeters of water in about 30 seconds. So see here, it's staying about the same. I mean, it's kind of hard because my thumb obviously isn't a perfect seal, but it stays about the same, so that's what you want. So there's no leak in your bag, which is a common spot, whether it could be a hole in it or something like that. And that means that my CO2 canister is properly seated, which is also a very important spot. And that also means that the gaskets for the breathing systems and how they're placed, because they're hand tightened, are tight enough. And that the manometer, or not the manometer, the flow meter is functioning properly. Okay, so I'm going to let go since we know that part works. Now we're going to check the vaporizer. So if you come here and you look here, there's a line which tells where the meniscus level would be on the SIBO machine. You want that to be at least up to that line. If it's low, you should fill it. It's not that difficult, so just fill it. That's the proper thing to do. So then the next thing you're going to do is run your system, make sure that that your pop-up valve is still closed, and you're going to turn it up, and I'm going to turn it up to about 5. Okay. So since I have the pop-up valve closed, it's just going to go up to here. Okay. Now notice how the ball is not dropping, so this means that we have a constant flow of oxygen. This is very important because if we didn't, then the ball would be dropping and then the patient would not be getting proper oxygen. So we notice that that's okay. So we can go ahead and just turn this off. And notice how the bag keeps getting bigger. So then we can open the pop-off valve. And then pretty much go on with the rest of our day, but always make sure that you check these CO2 absorber crystals by opening up your canister and taking it out. So the way they should look, they shouldn't be hard, which these are very hard because they need to be replaced because we haven't been using this machine. And they should not have any purple in it, and you should always leave a little bit of space in the top so that way the oxygen can run through the system here and be properly absorbed. If there's no space for the oxygen to go through, it's not going to do its job it needs to do. So always make sure that if they need to be thrown out, throw it out and replace it. Okay, so this is, like I said, a very common spot, so always make sure that this is seated properly. So I'm going to go ahead and just close this. And I'm going to make sure the pop-off valve is open, which I already did. And then you're pretty much set to